Dear students, in the previous lecture we have derived two important recurrence relations of Bessel's function. In today's lecture, we will discuss derivation of remaining four recurrence relations of Bessel's function. Let us talk over derivation of third and fourth recurrence relations in this particular slide. We begin again with first and second recurrence relations which we derived in previous lecture, named as equation 6.12 and 6.13. And third and fourth recurrence relations are very simple to derive. As you can see, if you add equation 6.12 and 6.13, means if you add first and second recurrence relations, and just by simplifying you will get third recurrence relation is derived. And if you subtract equation 6.13 from 6.12, means if you subtract second recurrence relation from first recurrence relation, and if you simplify you will get fourth recurrence relation is derived, and third and fourth recurrence relations are nominated as equation 6.14 and 6.15. So it's very easy to derive third and fourth recurrence relations for Bessel's function if you can derive first and second recurrence relation. So if in any kind of examination it is given to you to derive third recurrence relation, what will you do? You will derive first and second recurrence relations before doing further proceeding. That means after deriving first and second, you simply add them, you will get third one. And if fourth recurrence relation is there for derivation in examination, what will you do? Again you will derive first and second recurrence relation, then you will subtract second recurrence relation from 1, you will immediately get fourth recurrence relation is derived. So that is about first and second recurrence relations. All the time using that, third and fourth are easily derived. In next lecture, in next slide, we will discuss derivation of fifth and sixth recurrence relations for Bessel's function. Now we derive remaining two recurrence relations of Bessel's function. Fifth recurrence relation, as you can see, d by dx of x power minus n gn x equals to minus x power minus n gn plus 1 x. We start with left hand side, d by dx of x power minus n into gn x. Applying product rule of differentiation, we have first part x power minus n differentiated as minus n x power minus n minus 1 into second part jn x remains invariant, plus first part x power minus n remains invariant, and second part jn x differentiated as jn dash x. Then we are taking x power minus n minus 1 as common out of those two terms. Then we are remain with minus n into jn x plus x, because x power minus n is there, and we have taken x power minus n minus 1 as common, so it is x only into jn dash x. Please correct it, it is j and n is in subscript. Fine, j and x. Now what we are doing in next step, x power minus n minus 1 minus n jn x, first term remains invariant, plus in place of second term x jn dash x we are using equation 6.12. that means first recurrence relation is applied again. You can see first and second recurrence relations are extremely important for Bessel's function for deriving remaining four. Same was the story when we discussed sixth recurrence relation in Legendre's function. If you remember, first and second were independent derivations and remaining four were heavily dependent of first and second recurrence relation. Same story here in Bessel's also. So in place of x jn dash x, using first recurrence relation means equation 6.12, n jn x minus x jn plus 1x is written there. And why we utilized or applied first recurrence relation? Because minus n jn plus jn x plus n jn x, these two terms will cancel each other, and we are remained with minus n minus 1 power of x with x power 1 and with negative sign, so it's minus x power minus n jn plus 1x, that is about the required right hand side, named as equation 6.1c. so 6.16 is fifth recurrence relation. Let's talk over the last recurrence relation, that is sixth recurrence relation, d by dx of x power n jn x. There is a slight change in fifth and sixth left hand side, minus n there in fifth recurrence relation as power of x, and here we have x power plus n, and that is the required right hand side. What we have to do is start with left hand side, then use that property of product rule of differentiation. X power n is differentiated as n x n minus 1, jn x is invariant plus x power n invariant, jn x is differentiated as jn dash x. Then take x power n minus 1 as common. Now in bracket we have n jn x plus x j n dash x. Same like there in fifth recurrence relation. Up to this stage x j n dash x was there, x j n dash x is here also, and there we used first recurrence relation, that is equation 6.12. Here x j n dash is to be replaced by minus n j n x plus x j n minus 1x using 6.13, that is equation 6.13 means second recurrence relation. We know that left hand sides of first and second recurrence relations are same x j n dash, but the right hand sides are different. There we utilized first recurrence relation 6.12 equation, and here second. Why? Because there minus n j n x was cancelled with plus n j n x, and here using that second recurrence relation, here you can check that plus n j n x is cancelled with minus n j n x. That is the reason why we utilize 6.12 there and 6.13 here. Now we are remained with that only one term in bracket x j n minus 1x, it's multiplied with x power n minus 1 already available outside. So finally by mixing these we have x power n into jn minus 1x, the required right hand side of sixth recurrence relation, and equation 6.17 is representing sixth recurrence relation. So 6.12, 13, 14, 15, 16 and 17, these six equations which we derived in two lectures, previous one and the current lecture, and we derived six all important recurrence relations. You have to remember the derivations as well as their results, because from next lecture we will be discussing practical problems based over how many derivations we have completed in Bessel's function. If you think over two previous lectures, we initially derived generating functions concept for Bessel's function, then orthogonal property for Bessel's function, then previous lecture was therefore deriving first and second recurrence relation, and in today's lecture we derived four recurrence relation, remaining four recurrence relation. So from next lecture we will be discussing practical problems based over all these derivations of Bessel's function.